In this video, we're going to complete the KutaSoftware Infinite Calculus free worksheet, Higher Order Derivatives. I'll leave a link in the description below so you know how to access this worksheet, and I'll also leave a link to my Patreon page below, so click on that for more ways to support me. Now, so far, when we find the derivative, we're finding the first derivative. Higher order derivatives are finding the second derivative, third derivative, and so on. To find the second derivative, that's the derivative of a function. Finding the third derivative, that's finding the derivative of the second derivative. So for numbers 1 through 8, for each problem, we're to find the indicated derivative with respect to x. Number 1 asks us to find the second derivative of y equals negative x squared. So first, we're going to find the first derivative and then find the derivative of that in order to calculate the second derivative. So dy dx, the first derivative, equals, remember, using the power rule, bringing down that 2, and then decreasing that exponent value, n times x to the n minus 1, that's going to be negative 2 times x to the 2 minus 1, which equals negative 2 times x to the first, or simply x. Now that we have the first derivative, we're going to use that to calculate the second derivative. So the second derivative is going to equal the derivative of negative 2x, which, when using the power rule, the derivative of negative 2x, if this x is to the first, this is negative 2 times 1 times x to the 1 minus 1. We're bringing down that value of 1, and we're decreasing the exponent by 1. So that's going to equal negative 2 times 1 times x to the 0. Therefore, the second derivative of y equals negative x squared is negative 2. Because negative 2 times 1 times x to the 0, which is 1, is negative 2. Now on to number 2. For number 2, we're finding f double prime. That's the derivative of f prime, so the derivative of f of x. So f prime, or the derivative of f of x, equals 4 times 3x to the 3 minus 1. Multiplying the coefficient by that value of 3, and then decreasing the exponent by 1. So 4 times 3 is 12, and x to the 3 minus 1 is x squared. So our first derivative is 12x squared, but we're finding the second derivative, f double prime. So f double prime of x equals the derivative of f prime of x, which is 12x squared. So what we're going to do is take that constant 12 and multiply it by the derivative of x squared. So that's going to be 12 times n times x to the n minus 1. 2 times x to the 2 minus 1. So the second derivative is equal to 12 times 2, which is 24, times x to the 2 minus 1, which is x to the 1, or simply x. So the second derivative in number 2 is 24x. So again, remember, for that power rule, just a reminder, we're essentially taking this exponent, multiplying it by the coefficient, because we can pull that constant out. So this exponent's value will always get multiplied to the coefficient, and then after that, we'll decrease that exponent by 1. So right away, you can see 3 times 4 is 12, and 3 minus 1 is 2, so 12x squared. Then, multiplying 2 by 12, that's 24. 2 minus 1 is 1, so that's 24x to the first, or 24x. Now on to number 3. In number 3, we're finding the third derivative. So we're going to find the first derivative, the second derivative, and then the derivative of that second derivative in order to get the third derivative. So the first derivative, dy dx, is going to equal negative 4 times 1 times x to the 1 minus 1, because x has an exponent of 1. So that's just going to be simply negative 4, because 1 times any number is that original number. So we're taking 1, multiplying it to negative 4, and then 1 minus 1 is 0, and we know that x to the 0 is 1. So whenever we have x to the first, the derivative of that is going to be the coefficient. So the first derivative of negative 4x is negative 4. Now we're going to find the second derivative. And the second derivative equals the derivative of the first derivative, which we got to be negative 4. So for the second derivative, we're taking the derivative of a constant, which we know is 0. So that second derivative equals 0. And taking the third derivative, we're taking the derivative of 0. But 0 is a constant, so that's just going to give us 0. So the third derivative with respect to x is equal to 0. Let's continue on to number 4. And number 4, we're finding f triple prime, or the third derivative of f of x. So first derivative of f of x, that's going to be 5 times 4 times x to the 4 minus 1. 4 times 5 is 20, so 20x to the 4 minus 1 is going to be 20x to the third. Now, time for the second derivative. And the second derivative of x is the derivative of that first derivative, which is 20x cubed. We're going to have 20 times 3x to the 3 minus 1, which we can think of as taking 3, multiplying it by 20, and then decreasing that exponent value by 1, which is 60x squared. So we have the first derivative, taking the derivative of the first derivative gives us the second derivative, and now we're going to find the third derivative, which is the derivative of that second derivative, which is 60x squared. So the derivative of 60x squared is 60 times 2 times x to the 2 minus 1. 2 times 60 is 120, and then 2 minus 1 is 1. So this is going to be 120 times x to the first. So our third derivative equals 120x. And notice that I'm keeping my notation the same throughout. Because this function is written as f of x, I'm finding the third derivative of f of x, whereas in number 3, my function was y, and I was finding the third derivative of y. So the third derivative of y with respect to x is written as d3y over dx3. So if I was taking, let's say, the fifth derivative, using function notation, that would be f5x, the fifth derivative of x, and the derivative of y with respect to the x, that would be d5y over dx5. So depending on how the problem is stated, depends on your notation. So just keep that in mind as we continue on. So let's move on to number 5. In number 5, we're finding the fourth derivative. So, finding the first derivative, we'll get negative 5 times 4 times x to the 4 minus 1, which equals negative 20 times x to the third. Now we're going to find the second derivative, which is the derivative of that first derivative, negative 20x cubed. So that's going to equal negative 20 times 3x to the 3 minus 1, which we know 3 times negative 20 is negative 60, so that's negative 60 times x squared, because 3 minus 1 equals 2. Now we have the second derivative, so it's time to move on to the third derivative. And the third derivative is the derivative of the second derivative. So the derivative of negative 60x squared. That's going to equal negative 60 times 2 times x to the 2 minus 1, which equals negative 120 times x to the first. And now that we have the third derivative, we can use that in order to find the fourth derivative. So the fourth derivative equals the derivative of the third derivative, which is negative 120x to the first, or simply negative 120x, which we know will give us negative 120, because x to the 1 will become x to the 0, and 1 times that coefficient is negative 120. So the fourth derivative of y with respect to x is negative 120. Now let's move on to number 6. In number 6, we're going back to finding the third derivative. However, now as opposed to our functions only having one term, they have two. So we just need to remember the sum and difference rules when calculating the derivative. So the first derivative in number 6, dy dx, is going to be 3 times 5x to the 5 minus 1 minus, because that 2x is subtracted, 2 times 1 times x to the 1 minus 1, which we know will just be 2. So that's going to give us 3 times 5, which is 15, times x to the 4, or x to the 4th, minus 2. This is my first derivative. Now that we've found the first derivative, we're going to find the second derivative, which is the derivative of the first derivative. So 15x to the 4th minus 2, we're finding the derivative of that. So that's going to equal 15 times 4 times x to the 4 minus 1 minus the derivative of a constant, which is 0. So for the second derivative, 15 times 4 is 60, so we'll have 60 times x cubed. And now that we have the second derivative, we'll be able to find that third derivative, which is the derivative of the second derivative, which is 60x cubed. So that's going to be 60 times 3 times x to the 3 minus 1, which equals 180x squared. So the third derivative is 180x squared. Now on to number 7. For number 7, we're finding that third derivative. So finding the first derivative, dy dx, we'll have negative 2 times 3 times x to the 3 minus 1 minus 4 times negative 3 times x to the negative 3 minus 1. So negative 2 times 3 is a negative 6. X to the 3 minus 1 is x squared. So our first term, the derivative of our first term is negative 6x squared, and we're subtracting the derivative of our second term. So 4 times negative 3 gives us a negative 12, but as opposed to subtracting a negative, I'll add a positive 12, and x to the negative 3 minus 1 is x to the negative 4. That is my first derivative. So let's move on to the second derivative. That's going to be the derivative of my first derivative, which is negative 6x squared plus 12x to the negative 4. So that's going to be negative 6 times 2x to the 2 minus 1 plus 12 times negative 4x to the negative 4 minus 1. Remember, taking that exponent, multiplying that value by the coefficient, and then decreasing that exponent by 1. That's a simple way to think of the power rule. So negative 6 times 2 is negative 12, and that's x to the first because 2 minus 1 is 1. And then I'm going to be adding that to 12 times negative 4, which is negative 48, x to the negative 4 minus 1, which is x to the negative 5th. Now I can write this as adding a negative, but that's also the same as subtracting the positive. So this can also be written as minus 48x to the negative 5th. But now, finally, finding that third derivative, that's going to be the derivative of our second derivative, negative 12x plus negative 48x to the negative 5. So the derivative of negative 12x is negative 12, and then I'll be adding that to the derivative of negative 48x to the negative 5th, which is negative 48 times negative 5 times x to the negative 5 minus 1. So this is going to equal negative 12 plus negative 48 times negative 5 is a positive 240, and that's x to the negative 5 minus 1, which is x to the negative 6. So now, simplifying, I'll have the third derivative of y with respect to x equal to negative 12 plus 240 over x to the 6. Because remember, if we have a negative exponent, that's the same as writing 1 over x to the positive exponent. So our answer in number 7 is negative 12 plus 240 over x to the 6. Now for the last problem in this section, number 8. We're finding, again, the third derivative. So let's start with the first derivative. Negative x squared, the derivative of that will be negative 2x to the 2 minus 1, which is x to the first, or simply x. And then we're going to add that to 2 times 2/5 x to the 2/5 minus 1, which that 1 I'll write as 5/5. And that's because we have the fifth root of x squared, which can be written as x squared to the 1/5, and the rules of exponents, we're going to multiply those exponents together to get x to the 2/5. That's how I did 2 times 2/5 x to the 2/5 minus 1. N times x to the n minus 1. So that's going to be negative 2x plus 4/5 x to the negative 3/5. So here we have the first derivative. Now we're going to find the second derivative. So the derivative of negative 2x is going to be negative 2, and we're going to be adding that to the derivative of 4/5 x to the negative 3/5. So it'll be 4/5 times negative 3/5 x to the negative 3/5 minus 1, which I'm writing 1 again as 5/5. So our second derivative is negative 2 plus 4 times negative 3 is going to be negative 12, and 5 times 5 is 25, so negative 12 25ths times x to the negative 3 minus 5 all over 5, which is negative 8/5. So here we have our second derivative. Now we're going to find the third derivative. And that's the derivative of our second derivative, which is negative 2 plus negative 12/25, or minus a positive 12/25, x to the negative 8/5. So the derivative of our first term is the derivative of a constant, which is 0. And we're going to be adding that to the derivative of our second term, which is negative 12/25 times negative 8/5 times x to the negative 8/5 minus 1, or minus 5/5. So negative 12/25 times negative 8/25 is going to be a positive, and 12 times 8 is 96, and 25 times 5 is 125, and that gets multiplied by x to the negative 8 minus 5 over 5, which is x to the negative 13 over 5, or negative 13/5. Therefore, at number 8, my third derivative of y with respect to x is 96 all over 125 x to the 13/5. 96 over 125 x to the 13/5 is my solution in number 8. Now let's move on to the critical thinking questions. For 9 and 10 it says to find the indicated derivatives with respect to x. So let's take a look at number 9. At number 9 we're finding the 100th derivative of y equals 99x to the 99. X to the 99th. But quickly, I want to note, looking at the exponent and looking at the derivative, let's go back up firstly to number 7. In number 7, we are finding the third derivative of our function. And within our function, we had an exponent of 3. So when we found that third derivative, eventually we found x to the 3 minus 3, which was x to the 0, which was 1, and that was multiplied by our constant. Because we did x to the 3 minus 1, which gave us x squared, then we did x to the 2 minus 1, which gave us x to the first, and then we did x to the 1 minus 1, which gave us x to the 0. So the nth derivative of a function to the n is going to be the constant. And again, I'm ignoring this second half and just looking at the first half of number 7. So now, as you can see in number 8, if we go past that, here we're doing the third derivative, but let's look at this x squared value, ignoring this second half. If we were taking the second derivative, remember that gave us a constant, so then going a step further, taking the third derivative, a derivative value that's 1 past the value of the exponent, we're taking the derivative of a constant, which is 0. So here in number 9, we have x to the 99th, and we're taking the 100th derivative, but the 99th derivative would be a constant, and the derivative of a constant is 0. So in number 9, the 99th derivative is a constant, so the 100th derivative is 0. And let's quickly go through a couple of those. So the first derivative, ignoring the constants in front, that first derivative is going to be some constant times x to the 99 minus 1. That second derivative is going to be some constant times x to the 99 minus 2. Because 99 minus 1 was 98. 99 minus 2, we're going to 97. So then if you're looking at the third derivative, that's going to be some number or some constant times x to the 99 minus 3, so 96, and so on, all the way up to the 99th derivative, which equals some constant times x to the 99 minus 99, which is x to the 0, which we know x to the 0 is equal to 1. So we have 1 times some constant, which is a constant, and that's why when we take that 100th derivative, we get 0, because it's the derivative of a constant. So now let's expand this knowledge and look at number 10. In number 10, we're finding the 99th derivative of x to the 99, which we know is going to be a constant. Well, let's write out a few iterations. So our first derivative is going to be 99 times x to the 99 minus 1. So then our second derivative is going to be 99 times that exponent value of 98, which I'll still write as 99 minus 1, times x to the 99 minus 2. Because now, here we have 99 times 98 times x to the 97, and that was for our second derivative. So for our third derivative, we're going to have 99 times 98, which I'll write as 99 minus 1, then times 97, 99 minus 2, times x to the n minus 1 is 99 minus 3, because 99 minus 2 minus 1 is 99 minus 3. And this will continue on up to 99. So we'll have 99 times 99 minus 1 times 99 minus 2 times 99 minus 3 all the way to 99 minus 98 to the x times 99 minus 99. This was the previous exponent, 99 minus 98, and then we took away 1 from that value to get 99 minus 99, which is x to the 0, and we know that x to the 0 equals 1. So essentially, for this derivative, we have 99 times 99 minus 1 times 99 minus 2, and so on, all the way up until we're multiplying by 1. And if you recognize, this is a factorial. So for number 10, the 99th derivative of x to the 99th is equal to 99 factorial. And with that last question answered, we wrap up our higher order derivatives worksheet. If you have any questions, leave them in the comments below. And as always, like, subscribe, and share to show your support. So doing any of those three or all of those three, let me know that you're finding these videos useful, which encourages me to come out with more videos for you.